Welcome back to the Hyperbolic Coding Chamber. It is December 31st, and you're back again for another day of suffering. So, yeah, definitely don't have a lot of brain juice today. So, not much to reflect on except the process of reducing the brain juice abuse is underway. So, adding more restrictions, hoping that the come down will not be as bad. And I think things are going well for now, but I've been doing a lot of reading, so that's been a pretty cool thing to do. So hopefully we can pound through more books. Also, The Nature of Code is an absolute cheat code. Daniel Schiffman, I think, is the second coming of the most legendary computer scientist to ever exist. There's just a way that he writes the book, Nature of Code, that is just is fire. So it's just Nature of Code, if you don't know, is just a book it's a book that's free, which is also dope, but you can also pay for it, which is also dope. And it's just about pretty much like introduction to like visual programming, sort of, through like a math-based perspective using processing, which is pretty dope. So that's been pretty cool to do. And yeah, it's just a joy to read the book, and yeah, I'm just grateful that he exists. So that's pretty cool. That being the case, yeah, I don't have a ton of brain juice. Actually, I do, but we're actually strapped for time, so I'm actually just going to jump straight into LeetCode. But at the same time, make sure to join the HCC, a Discord dedicated to the preservation of LeetCode as an art form. So if the HCC interests you, you should definitely join the Discord. And yeah, we're going to do a big bust down Rolly Avalanche party at day 365, so you should definitely join the Discord for that as well. So that being the case, I don't think there's much else to do but sign up for our daily suffering. And it's not really suffering at this point. Honestly, we just kind of have to get it done because we're strapped for time, but I'm not exactly dreading this session. So I guess that's one of the benefits of employing the stabilization factors. So I'm not exactly dreading the session, we just don't have a lot of time, so I kind of have to jump straight into it. So that being the case, wait a second, I feel like this song is very loud. Okay, this should be better, I think. That being the case, we're just gonna jump into it. So have some LC open. And I think we still have not too large of a number of problems done. And I think what we're doing today, we got stuck on because we only didn't have too much time. We had this problem which had to do with permutations and pairs of numbers. I think we have a way to solve it now, but I forgot where we left off, so let's see. Permutation perm of n plus 1 integers of all the integers in the range 0 through n can be represented as a string s of length n. A string s of length n. Right, and they kind of tell us this. Permutation of n plus 1 integers can be represented as a string s of length n. Given a string, so s sub I is equal to I if perm sub I is less than perm sub I plus 1, and s sub I is equal to d if perm sub I is greater than perm sub I plus 1. Given a string s, reconstruct the permutation perm and return it. If there are multiple valid permutations perm, return any of them. I wonder if there's guaranteed at least one answer. There probably is. They don't say though what we should return in case there's no permutation, which doesn't make sense. So I think what we decided to do is try to find some cheat code that we could intuit to make this make sense. So it looks like we had perm of range ID, right? Which means that we should have, for each letter, we should have a pair of numbers corresponding to that relationship between the size of the numbers. And based on if it starts with an I or a D, we plan to do some work. So it looks like what we decided to do is split the groups up like this. If we have a group, if we have two I's and two D's, we split it up so that we have half and half, I guess. Right, I think it's all coming back to me. This one starts with I, which means that we should start with the smallest number to start, which should be 0. So this automatically reduces the possible numbers we can choose from. So we have 4 numbers remaining. So what group should go into both groups D and group I? In this case, we have half case of ID and ID, so we should split them up evenly. But let's just say we had something like this, ID, right? If we had ID, right, we'd lose X. We'd lose 4, which means we'd have 2 I's to 1 D, which maybe means that we should have the extra number should go to I instead of D. In that case, we could put 0 first because we want increasing, then we could choose 3, right? Then we want decreasing, then we could choose the one number in decreasing, which is 1, and then we could place 2, which would be increasing. So if that's the case, it seems like based on whichever exists more of I or D gets the extra number. The extra number here being 2. So in this case, we count all the I's and we count all the D's, we end up with more I's than D's. And then here we try to split up the numbers into decreasers and increasers. So if num D does not equal num I, can we assume that they have the same number of numbers in both groups? So if we return back to our initial example with ID, we had 2 D's and 2 I's. Subtracting 0, or subtracting the last number. I guess there's 2 cases here. We can either subtract 0 at the start, or subtract the number, the first number or last number at the start, or don't subtract it at the start. So we have a choice to make. Take first number at beginning or before we assign nums to groups. I don't really know which one would make the most sense first. So let's just say we remove it first. That's what we kind of have written up here. If we remove it first, we have ID with 1, 2, 3, and 4. We have 1, 2, 3, and 4. Then num D does equal num I because we have 2 D's and 2 I's. If that's the case, then the midpoint would be equal to s.length over 2. So if we check s.length though, s.length is 4. So it'd be over 2. In this case, you actually end up with 5 total characters because it represents a permutation of n plus 1. If you remove 1, basically you'd get index 2. If you had index 2, you'd go from, we would add index 0, index 1, right? And then we'd start at mid plus 1, which would be index 3, right? And we'd want at 3, we want it to be less than nums.length, so we'd also add in the last index. So in this one's current state, at least for the first case, we should be getting the numbers split up correctly, except we're not removing the number first. So if we can find our output array, which we removed, if we just grab this up here, we'll uncomment this out. And if s sub 0 is equal to d, we'll do output.pushNums.pop. Otherwise, we'll do output.pushNums.shift to get the largest number at the end. From there, we don't want to do s.length. We want to do the remaining numbers in output.length. So we do output.length over 2. This code won't run since num_i will be equal to num_d. At least I thought it wouldn't run. Oh, not output. Nums. The numbers remaining. So we're still missing. Right, we wouldn't actually do +1 because the midpoint we stopped before the midpoint. So we want to actually include the midpoint. So we get a perfect split here, which is correct. Now the problem is, let's just say we run this same case back, except it's something like something like DDI. Something like DDI, we should have 0, 1, 2, 3 to consider, but we're missing 3. But I think that's actually fine, because if we check output, we should see that 3 exists in there because it's the largest number. If we check case 3, right, so output is in there. Since output is in there, it's splitting correctly when we have more decreasers than increasers. What about when we have more increasers than decreasers? What if we change it to something like IID? I didn't want to overwrite that test case actually. So now our output actually starts with 0. We have nothing for increasers. So we should have 0, 1, 2, 3. Starts with I, so we should have 3. Or starts with I, so we should have 3 in output. But we have 0 in output, which doesn't make any sense. If it's D, we take the largest number because we want to be able to decrease anywhere. If it's I, we would take the smallest. Right, no. This should be 0, which is correct. But we still have nothing for increasers, which is strange. No, we have nothing for decreasers. We basically want to split it in half. Basically want to split it in half always. Basically, we have 3 over 2 is 1.5. Floor is 1, minus 1 is 0. So you end up with no elements. comes out length over 2, which would be 3, we get 1.5 and 4. Ideally, what we'd like to happen is for each side to have one element. But if we're just adding one, then it doesn't make sense. You should get an extra one. Maybe you can only get an extra one here if you seal. If you seal, we should get an extra increaser. The index would be 2. The index is 0 and the 1. I think what the thing is, you can floor, you just don't have to. Yeah, because you have more increasers here, so you have an extra one. And I feel like it's going to get really messy because we need to add, if I reset the test cases, I add IID, and we run them all. Hopefully we have the correct groupings, and then from there we can just do the pulling. So we have an even number, right? So it's split even. We have all I's here. We're starting with 0, which makes sense. Here you could just take, since we want to show something increasing, we would just take something from the increaser, and if there's nothing there, we'll just take from decreaser from the front side. And then if there's DDI, we start with 3. We start with 3. And this one, a decrease, we want to take from decreaser, which would be 2. Right, then we have another D. So we would just take from the largest of increaser. Then we want to increase. Oh, no. I think so. We're starting with 3 and we want to decrease. So we just take the topmost decreaser, 1. 0, then we want to increase, we would take from increaser. So we have I starting with 0, we would take from increaser, right? And since there's no increase, we have 1, we add 1. We need another increaser, but it's empty, so we would just take from the front of decreaser. And then we have the decrease, so we can take from the end of decreaser. So basically what we're seeing here is that with ID, so from here, I think we already have our output array. All you have to do is say while letter of S, or for letter of S, const letter of S equals D, right? We're going to do said work, and then at the end we can return output. And so we're gonna have some special cases. This one has a lot of dislikes, I feel like. It does. So letter D, we're gonna say if decreasers dot length does not equal 0, then we can just say output dot push. If it's not empty, right, it means we can just take. If it's not empty, it means we can just take from. So we're starting, for example, in this case, starting with 0, right? The next number that makes sense to take from is you have increaser. So you want to create that increasing relationship. So we have I. We take from increasers, which is the second array. would just take from the end of it, I believe. Decreasers dot pop, right? Otherwise, if it's empty, if decreasers is empty, then we want to take from increasers, but from the front. And we can duplicate this. If increase length is not equal 0, then we want to take from increasers end. Otherwise, if it's empty, we want to take from decreasers, right? So if we look at a case where increasers would be empty, something like DDI, right? Our output is 3, our increaser is 2. The first thing we want to represent is a decreaser. So we would take from the front of the decreaser, which is 1. Then we want to represent decreasing again, so we take the front of decreaser, which is 0. Then we want to increase, so we just take from the front of increasers. And then let's just say we have no, let's just say this was just DD. You'd have 0, 1, 2. We start with 2 as our number, right? We'd like to take from I think you would just take from you would just take from the decreasers' front. No, I think you take from the decreasers end. Because if you're increasing, you want to increase by the largest possible amount possible, and that would be at the end of decreasers. So let's just see if this makes sense. So they want us to represent IID here. We output 0 to 3 is increasing, 3 to 2 is not increasing. So what's happening here, we start with 0. Since the number is increasing, we want to go to increase by any number. So we take from increaser, which would be n, which would be 3, right? Then we go to I, we'd like to increase it. Oh wait, when we increase, we'd like to do it from the front so that we can still increase later. And here we have a problem because we'd like to increase completely, but all of our increasers we should be taking from the front. So we'd start with 0. I'm guessing we should also be probably failing the test case where we have something like DDD. Right, so we have these two. If we check the letter equals D, right? So we do output dot push decreasers dot pop. So we have 1. And I think we could add one more case. This is really messy, but we're just gonna do it this way anyway. have an else if numd, right, equals 0, or numi equals 0. It means one of the two is just, it means one of them is just all it means one of them, the string is all one relationship. So if numi equals 0, numd equals 0, then we should just load it all into the string. Load it all into the output. So if it's num I that equals 0, that means that the array is all decreasing. If it's all decreasing, this is so ghetto. We're just gonna say I guess we'll just do it like this. We'll say const O is equal to, this is just another output, which is really bad, but kind of it is what it is. We'll just do I is equal to 0. If I is equal to 0, it means it's only decreasing. So we'll set I equal to s dot length. Say well I is greater than or equal to 0, I minus minus. We're just gonna say O dot push I, and we'll just say else it must be only increasing. I be equal to 0, I is less than s dot length I plus plus, and then we can just return O. It still didn't work. Oh, I meant to say or. And then we'll say equal here. Oh man, it doesn't pass. Zero, 1, 2, 4, 3. You know what I'm thinking now? I think we could just do this. You know what I'm thinking now? What if we scratch this whole thing and visualize this as a graph where the nodes are going to be, well, the vertices would be 0 to n inclusive, and it'll be 0 through n, and the edges every vertex would have an edge. It'll be fully connected graph. Every vertex would have an edge to every other vertex, and what we'd be tasked with is, actually no, I don't think this would work because the graph would be massive because s goes up to 10 to the 5th. We're basically just searching for a path such that I wonder if this is a topological sort problem. I haven't read a lot about topological sort. But it feels like that might be what this is. You'd have 0 to 3. So we could have a relative ordering amongst the vertices because I still feel like there's a simple solution to this. This seems zero to 4. I think we can actually still use this. Yeah, I just realized something's wrong here, because we should have more group. We should have 2 in the increasing, but we don't. If we did, we would have taken 2, 3, 4, and then placed 1 at the end. So I think in the case where we have more I's than D, I thought we tested this. We should have an IID here. An IID in this case. We didn't check an IID when it's odd. And this problem, IID. There's problems like this I've had before, where based on whether or not the input is even or odd, it changes. You have to have like duplicating cases. Because nums.length divided by 2 doesn't work as well here. Because it'd be when it's odd, you should always get 1 more extra. If I had -1, then this case passes, but this one fails. And so you just can't do this simple thing that I'm trying to do here. And there's probably more cases for both, so we should just say num_d is greater than num_i. Right, then we should have decreaser. Else we should get 1 extra increaser. But how you get that increaser is dependent on whether or not nums.length over 2. If it's even or not. If it's even or not, we can actually just say subtracted by nums.length mod 2. Because in the case with IID, we don't have any increasers because we get too many. So we should have 4 numbers. We subtract when we have 3. We should have 1 decreaser and 2 increasers. If we remove the -1, then a different test case passes. Now that I realize it, I think you can just still remove this line and this should still work. I might have to floor it actually. And then based on some cases here, we can add one or subtract one. Never mind. Right, and it's only in the case when the decreases aren't equal to the increasers. You may have to add one or subtract one. If I say here mid plus equal 1, then that other case should start passing again. Wait a second, maybe I'm overcomplicating this. If I remove all this midpoint nonsense and all the stuff where we create this increaser decreaser nonsense, and I remove the special case nonsense, sometimes push. Isn't the whole thing just about if it equals D? If it equals D, then to guarantee that it decreases, we should take a number from the front of the array. Because if we started with something like I, if we started something like I and we want to increase, we'd start with 0 in the output. Now we're back at I, we want to make sure it increases. We could just take I think there's a better way to slot them into groups. Let me just say for let I is equal to 0, I is less than num sub I plus plus. To get an increaser, you would just push nums dot pop. Or if you wanted them in a particular order, you could do nums dot unshift, nums dot pop. And then for num d, for the decreasers, you would just you would also just unshift nums dot pop. There was a console.log in here somewhere. Dang, feels bad, man. So we got it in the end, and I realized I was hyper fixating on putting them into groups in a way that I understood, but that made the code really complicated. There was another way to put them into those same groups when I abstracted up a little bit higher. So I'm thinking maybe I ran into this issue in another problem because I was set on putting up the groups in a way that made that my original way. But there was another way to split it into groups. You get the same outcome. I would say this is linear time, even though we go through the array a couple of times in a way. With linear space. This unshift though is problematic, so maybe it would make some sense to use something like a deck here. So actually, I would say it's n squared just because of this portion right here with the unshifting. I think we could save the space if it's actually no, because we have to create the nums array. So it's not the slowest thing in the world. I wonder, I think you could have definitely done this with 2-pointer string greedy. Yeah, this one, I feel like it takes, yeah, there's a way that I feel like I had to split up the strings, but sometimes I get caught up in a stepwise solution. There's another way to accomplish the same exact thing that I'm trying to do without getting stuck on something that's giving me trouble. So that was an interesting question. That was kind of difficult though. Or it took us about like 2 days. So this one has a legendary number of dislikes. So we have to design a class to find the kth largest element in a string. Note that it is the kth largest element in the sorted order, not the kth distinct element. There's the kth largest element in the sorted order. So if they're giving a number like 3, we should find the third largest element. Implement kth largest class. Kth largest int sub k nums initializes the object with the integer k. Initializes the object with the integer k. Initializes the object with the integer k in the stream of integers. Num. Int add appends the integer val to the stream and returns the element representing the kth largest element in the stream. This definitely seems like a heap problem. I'm not certain how long insertion takes in a heap. I know retrieval takes log n. So if you wanted to find the or I guess you could do something where you have an array of numbers, you add the number to the array, but you need some data structure that automatically sorts the elements. I'm thinking of another method where we could add, if we just throw it all into an array, when you add the number, we'll sort the array, and then we'll return, you know, the kth largest value, which would just be the array sub k, the array's length minus k, maybe minus 1, maybe not, but if we do that, every time you call add, if you were to call add successively, which assuming I guess we would, if we were to call add n times, the average runtime of add would be n log n. It would be n log n squared. Can we do better? Can we do better? You add 3, the kth largest element is 3. If you had 5, the third largest element would be 5. If you had 10, the 10th largest element would be the third largest element would be 10, 8, 5. Three, 5, 10. Tenth largest. You have 10, 8, or the third largest would be 10. You have 10, 8, and 5. 5 would be the third largest element. Oh, right. This is not the output. This is just input. Then you had 9, then it'd be 8. probably, what if we just searched? If we did a linear search through the array for the number, we could probably get linear time. So then you'd need k variables. Maybe it wouldn't be that simple, actually. I feel like this is the best. Maybe the best bet is heap. If you use the heap, then you could load the values into the heap. I'm not certain how long that takes. If we load the values into the heap on add, then if we wanted the kth largest value, then we would just have to do log of k to get the largest value. But I'm pretty sure there's a self-ordering property of binary heap that may not be that simple because we'd be calling both of them. How large can k be? K can be up to 10 to the 4. There's no way we we'll stop there.